You know that feeling on a crazy hot day? You flip on the AC and it feels like pure magic? But how does it actually work? Well, it's probably not what you think. Let's break it down.
So picture this. It's a scorcher outside. You walk in, you flip that switch, and boom, that blast of cold air saves you. Seems simple enough. The AC is just making cold air. But what if I told you that's not what's happening at all?
Okay, so here's the thing. Your air conditioner doesn't create a single molecule of cold. Not one. It's actually performing this really clever trick. It's not making something new, it's moving something that's already there. And that, my friends, brings us to what I like to call the big cooling lie. Basically, how we all think about getting cool is kind of based on a complete misunderstanding of the actual physics involved. You see, from a physics standpoint, cold isn't really a thing. It's not a substance you can just pump into a room. Cooling is actually the absence of heat. It's the process of removing heat energy. So your AC, it's not a cold maker, it's a heat mover.
Okay, so if the AC's job is to move heat, how in the world does it pull that off? Well, it has this little team of 4 key parts, all working together in a perfect cycle. So let's meet these heat movers.
All right, these 4 parts are basically the heart and soul of every single AC unit out there. First up, we have the evaporator. I call it the heat grabber. Then there's the compressor, aka the squeezer. Next is the condenser, which is the heat releaser. And finally, you've got the expansion valve, the pressure dropper. Each one has a super important job.
Now, the whole process hinges on this special liquid called refrigerant. Think of it as our hero in this story. This stuff is amazing because it has a super low boiling point, which means it can absorb and dump heat like a champ. And it goes on this endless journey through those 4 parts, grabbing heat from inside your house and just chucking it outside. Okay, let's follow the refrigerant on its trip. So first, inside your house, that super cold liquid refrigerant is flowing through the evaporator coils. A fan blows your warm, stuffy room air over these coils. The refrigerant is like a sponge. It soaks up all that heat, and in the process, it turns from a liquid into a gas. And that now chilled air? That's what gets blown back into your room. Okay, step 2. Our refrigerant, now a warm gas, travels to the compressor. The squeezer does exactly what its name says. It squeezes that gas, which ramps up the pressure and makes it get super hot. Right, step 3. This really hot, high-pressure gas now moves to the condenser unit. That's the big box outside. Another fan blows the outside air over the coils and poof, all that heat it picked up from your living room gets released. This cools the refrigerant down enough that it turns back into a liquid. And finally, step 4. This now cooler but still high-pressure liquid goes through the expansion valve. This valve causes a massive drop in pressure, and when that happens, the refrigerant gets intensely cold again, ready to go right back to step 1 and grab more heat. It's a continuous loop.
You know, that third step we just talked about, where all the heat gets dumped outside, that is absolutely the key to this whole magic trick.
So, you know when you walk past that unit in your backyard and you feel that blast of hot air? Yeah. That is literally the heat from inside your living room. The AC captured it and just kicked it to the curb. I know. This whole pressure and temperature thing can sound a bit like a science class lecture, but there's a perfect everyday example that I call the spray bottle secret that makes it all click.
Okay, think about a can of compressed air for cleaning your keyboard, or even a can of deodorant. When you hold that button down for a few seconds, what happens? The can gets super cold, right? That's because the gas inside is expanding really, really fast. That is the exact same principle the AC's expansion valve uses to make the refrigerant ice cold. And the opposite is true too. The compressor squeezes the gas, making it hot, which is perfect for getting rid of that heat outside.
So why should you care about any of this? I mean, as long as it works, who cares, right? Well, because once you stop thinking of your AC as a cold maker and start seeing it as a heat mover, you can use it way more efficiently. You're basically trying to win the war on heat. Just imagine you're trying to cool a room, but you've left a door or a window wide open. You're just creating this endless battle. Your AC is trying to pump heat out, and the hot air is just marching right back in.
Yeah, your AC is fighting a battle it can't win. It has to run constantly just to keep up with all the new heat you're letting in. And what does that mean for you? A much higher electricity bill. You're literally paying to cool the entire neighborhood.
You know, if you had to boil it all down to one single sentence, this quote absolutely nails it. An air conditioner cools a room by removing heat from inside and releasing it outside using a continuous heat transfer cycle.
So look, If you forget everything else I've said today, please just remember this one crucial point.
ACs do not make rooms cold.
They just take the heat away. And now you know the brilliant and honestly pretty cool science behind that everyday magic. Thanks for tuning in.